Hey guys, how you going? Just want to talk you through some support and advice for writing mathematical investigations. So first of all, mathematical investigations will have a page limit, which is the maximum amount allowed. There's no word count for a mathematical investigation. The page limit doesn't include a title page, a reference list, or appendices. So if you, for example, did some calculations and you want to show that at the end as an appendix to prove and support the working out that you did, that doesn't include, that's not included in your word count. So really, you've got an introduction, the body, the discussion, and the conclusion, and that needs to fit within the page. Now, to save space in an investigation, if you're one of those people that you tend to write a lot and you're very detailed, which is good, you can do some things to maximize the area of each page. So in the layout, if you go to the margins and narrow them, then you've got more space in the borders, okay? Because the borders are narrower. And for paragraphs, you can change the space for before and after to 0 point and the line spacing to single. That gets your text a little bit bunched together. Your font must be typical, so Calibri is an example, Times New Roman, that type of thing. And it must be size 11, so you can't go smaller than that because otherwise it's not readable. So a pretty common trick, 12 font is pretty standard. You can just go down to 11. And have your file as something relevant to the investigation and your name. So example, polynomials investigation, Stuart Dent. So mathematical investigations are written without personal pronouns. So this is formatting. So don't say me, my, I. So this can initially be difficult to write, but the investigation itself needs to be the subject. Okay. So an example for personal pronouns. I'm going to calculate the mean, median, and mode and range for how many points LeBron James and Michael Jordan scored in the first season of their career to determine if my prediction of LeBron James being the better rookie is correct. Now, if you change that sentence to without personal pronouns, you can see in green versus red. So rather than saying I'm going to, you can say this investigation will calculate the mean, median, and mode, etc., and then say to determine if the prediction instead of my prediction is correct. Okay. So again, with personal pronouns, I found that LeBron James had a higher mean, median, mode, and range for points scored, which means my prediction was correct. You can instead say it was found and the prediction was correct. So try and use that or avoid those personal pronouns. Have a title page for your mathematical investigation. Okay, so have a relevant title. Picture is always good. Have the subject. You might have the teacher and have your name there as well. Okay. If you're in SACE, put your SACE number in there as well. Okay. So just that cover page makes it look nice and neat, and it makes it look more professional. So the introduction, you need 3 parts to it: the purpose, the parameters, and the process. The purpose is the context. So that's any relevant background knowledge or information required for the investigation. Outline the aim, what's trying to be achieved. Now, the purpose is usually stated in the investigation outline. So what I'm saying is you can look at the task sheet and you're basically just rewriting that. You might just condense it a little bit, okay? So any information that would be required to understand what you're doing and then what you're trying to achieve, that's your purpose. So that only needs to be 1 to 2 sentences. The parameters is the narrative, the setting, and the conditions for the investigation, how it's going to be explored or solved, including what is the outline of the structure and the method. So the initial parameters, again, are usually given in the investigation outline. So an example, the measurement DI that my Year 10 class is doing at the moment, the narrative and the setting is that you are manufacturing containers to ship school supplies, okay? So you're kind of giving that context. Now, the process is the mathematical concepts, the procedures, the formulae, and the models that are going to be used to support the purpose of the investigation and how they'll be used. So again, you're talking about what math is going to be used in this investigation and why is it going to be used. So for the measurement DI, we're using surface area calculations for nets of 3D shapes, and we're going to be using volume calculations for those same shapes. In most investigations, you would have some key terms. So any mathematical terms that you'd use to explain what they are and reference that source, and a prediction. What do you think you're going to be, what's going to be discovered, and justify why that might be. So that's your introduction. So here's an example. Now I'm not going to read these examples, but I just want to note, if I go back, this color coding, the purpose, the parameters, and the process, the prediction. Okay, so purpose in yellow, parameters, parameters, the process, and the prediction. So you can pause the video now to look at two examples of an introduction for two different mathematical investigations. And again, just try to look at firstly how it's written and then that structure. So have a go at writing an introduction for your mathematical investigation. Here's some more examples that you can use to support you. The next is the body of the investigation. This is the main part, okay? So this is going to include your calculations, graphs, displays, tables, any other information. This is the majority of your investigation, okay? The investigation outline will tell you what you need to do, and that should be closely followed. During the body, the following areas need to be consistently addressed and at times will overlap with each other. So the heading and topic sentence, each section and subsection should have a relevant title or a heading with a topic sentence outlining what processes are about to be undertaken and their importance. So each thing you do, you should have a heading, okay, and a topic sentence explaining what the reader is about to see happen, okay? Don't just throw your calcs in without giving it some context. Your process is important. Your working out needs to be shown, and the results and findings should be summarized using graphs, tables, or any other relevant display. Make it easy to follow your working. Then the analysis and interpretation. So after each section or subsection, an analysis, interpretation, and discussion should be undertaken to discuss the results. So what it's going to be about, the process to get there, and then analysis and implications of that process. And you might repeat this many times throughout an investigation. For example, the measurement DI that my year 10s are doing at the moment, they're doing 3 different containers. So this would be repeated 3 times. So here's an example of one section or one part of a borrowing or saving for a car investigation. So again, you can pause the video to have a look at this properly, but the blue is the topic sentence. So there's a subheading. There's a bit of an explanation about what's going to happen. There's the mathematical process in green, which is summarized neatly in a table. And then the analysis and implication to explain to the reader what analysis has occurred and what that shows. Okay, so the implication. Here's a second example for a greenhouse gas emissions investigation. Again, topic sentence, process, analysis and implication, back to a mathematical process, a further analysis, and another mathematical process. So here, there was no need to do a new topic sentence because these flowed from one to the next. So here's an example of another investigation. And all you need to see here is just to note how the body constantly flows from that topic sentence, the mathematical process, the analysis and implications, then back to the same thing again, back to the same thing again, back to the same thing again. So that order is consistently followed, okay? So now we have the discussion. So there are 3 main parts to a discussion, which are common to all mathematical investigations. In some cases in the senior years, some aspects of the discussion may be present in the body, but this will be made clear in the outline. So sometimes it can be slightly tweaked. But the 3 main aspects are the discussion of results. So this is to tie together the overall results. So previously in the body, you were talking about the significance of one part of math. But now this is the discussion of the entire body, okay? This isn't a summary or a recount. It is comparing results, identifying patterns and trends, including consistencies and inconsistencies. Interpretation involves finding meaning and giving possible explanations for the analysis of the results. So it's not just rehashing what you found, it's connecting that, analyzing that, finding patterns, linking to the real world. Then you have assumptions and limitations, where you identify these and discuss their effects. This can relate back to procedures for data collection, development and application of the model used, and the parameters of the investigation. And then reasonableness, where you can discuss reasonableness of the investigation, which has a direct relation to the nature of the assumptions and limitations identified. So the reasonableness connects with the assumptions and limitations. It's important to logically identify and discuss aspects of the model, the results and the trends in a real-world context that are both reasonable and unreasonable. If necessary, outline ways to improve the reasonableness. So let's delve into this in a bit more detail. So an assumption is information that's believed to be true in regards to the context, data, model, or outcomes found without actually knowing. Okay? A limitation is something that reduces or restricts the capacity to investigate it entirely. Often the parameters given in the investigation outline form some of the limitations. Reasonableness, I can't say that word for some reason, is a discussion about how likely the parameters, the mathematical process, and the results are reflective of what would actually happen in the real world. As a general rule of thumb, the more assumptions and limitations there are, the less reasonable an investigation is. So this is a year 11 example of a discussion for a calculus investigation. So in purple, we have the analysis, or the discussion which includes analysis. Blue, we have assumptions and limitations. And green, we have the reasonableness of the investigation. So you can pause the video and read an example of this discussion. So some other examples of assumptions, limitations, and reasonableness. Okay, so an example investigation in a previous section. So I'll just go back to that quickly. So this investigation is about, let's go up here. So this is the example investigation. Your family wishes to escape the cold winter of Adelaide in the July holidays and wishes to go somewhere else in Australia to a warmer climate. You need to select 2 cities and compare their daily average temperatures for the month of July to determine which city is a better option for your family to visit and display these results using a graph. So the assumptions for that discussion, we're assuming the family wanted to go to Townsville or Hobart altogether because those were the 2 cities that were being compared. They may have wished to go to another destination for their holiday. Now, one of the conclusions was to go to Townsville. So an assumption is assuming the family will go to Townsville based on its temperature alone, as there are other factors that are taken into consideration. So if the investigation is about which city is better for a holiday, you're assuming that only temperature, the temperature of the city is the only reason they want to go there. But obviously there are many other factors that you'd want to go somewhere for a holiday. So those are examples of assumptions. Example limitations. Now, if the investigation involves comparing 2 cities and their daily average temperature, you're limited to exploring only 2 cities, and the temperature had to be the deciding factor between them. There are obviously many other cities that could be investigated, and there are many other aspects of those cities that could be investigated. But we're limited because we only have a few weeks to do these investigations as a high school student, so we have to make limitations there. You're limited to exploring destinations that were interstate. There could have been a better destination in South Australia or overseas. Okay, so the investigation limited to interstate cities, not cities within our own state or international cities. Now, the reasonableness, temperature may be a factor when deciding on a holiday, but overall it is unreasonable as there are many other factors taken into consideration when choosing a holiday. This would include overall cost, appeal, interest of the destination, including potential tourists, and suitability for family dynamics, e.g., is it safe to bring young children? Okay. Would you bring young children to a very rural city or somewhere that's kind of dangerous? Families would also look at more than 2 options, and if possible, would potentially look at interstate or international destinations. So the reasonableness is low, or you could say it's an unreasonable investigation. The conclusion is the last bit. There are 3 parts, again, to a conclusion: the review, recommendations, and reliability. The conclusion is concise. You shouldn't bring up anything new. And we should go over those 3 sections. So the review, write a direct and concise statement that links the outcomes to the intended purpose during the introduction. So what you found, link it to what the point of the investigation was. This should give no numbers and no new information. In some ways, this can be considered the answer to the purpose. The recommendations would be recommending, based on the results and purpose, where you would go next. Okay. Now, this would only be appropriate if different options were being explored. Okay. So for the measurement DI that my year 10s are doing at the moment, they are recommending which container would be the most suitable to use. The reliability discusses the reliability of the results and recommends what to do next. Okay. So here's an example or 2 examples of conclusions. Okay. So first of all, we have the review, recommendations if appropriate, and then the reliability. So the first example here, it has a review, no recommendations because that's not appropriate, and it has the reliability statement. The borrowing or saving for a car example does have a recommendation of what to do. So I'll let you pause the video and have a read of that. The reference list is needed. Remember, this is not part of your word count. So for a reference list, you should try to use Harvard referencing because this is a system or a standard that's used at university. So here are some examples of references. You can use online reference generators. However, it's preferential if you learn how to write your own reference. Okay. So here are some examples of how to reference. First of all, websites and online documents. And here are some examples of how to in-text reference those documents. And lastly, an appendix. You can include an appendix and you would number them, appendix 1, 2, 3, etc. You can reference those in your investigation. So for example, if I had a sheet of working out for the surface area for a net of a shape, and I didn't want to include that in the main body of my investigation, I can refer to it as refer to appendix 1 and then include that at the end. It doesn't include towards the word count. So that's it, everyone. So that's some advice and strategies to write a mathematical investigation. Good luck, and hopefully this has helped in some way.